And it looks like, yes, maybe we are recording now. Nope, not yet. Yeah, there it is. Okay, now we are definitely recording. All right, now, first things first, tomorrow is another asynchronous day. Love the asynchronous days. You'll make sure you log into your attendance thingy, give me first and last name and class period, because like I said, all 170 of you guys dump into one big pile, and that helps me sort everybody out. Tomorrow's assignment is going to be your study guide. The test for this chapter is Friday. The study guide is designed to last 3 days. So do not let yourself freak out when you look at it. Okay, do not freak out when you look at that study guide. It is designed to last 3 days. Take your time, and you want to get the answers correctly so that you can use that. That's the material that's on your test for Friday. Okay, you want to do well and get the correct answers. What we have today is the last discussion day. And it looks like I am already sharing my screen, so that is good. Slide this over here so that I can still see y'all. The assignment for today, we have, you can see here on my Schoology, that way. No, try again, hold on. Try again. Sorry, I'm trying to get to where I can see all of the pieces at one time. All right, so you have an assignment that's a reading about the American alligator and the shark as keystone species. I'll tell you more about that as we get into class, and they each have 5 little questions each. That's going to be due on Wednesday. Let's go ahead and begin our discussion for today. Now, again, the test for this chapter is on Friday. And so let's see if I can pull this a little bit bigger. And this a little bit. Yeah, this will work. All right, so we started off with this chapter learning about habitat versus niche. Okay, and we said that habitat is just where the organism lives. Niche is how it lives, how it gets its food. What does it eat? What it eats it. Does it have any kind of adaptations to hide from its predators, or extra, if it's a hunter, to catch its prey? Does it have any special tricks that it does when it goes look for mates, like the birds when they do their fancy dances to find their mates? Does it have anything like that? Does it do anything in the ecosystem that changes it, like beavers cutting down trees? That's all part of that organism's niche. Habitat, just where it lives. So habitat is where it lives, niche is how it lives. And then we also talked about the difference between specialist versus generalist. And my baby kids, the ecology kids, they were learning about coevolution today. And there's this bird called a lobelia flower that has a really deep pocket in here. That's where the nectar is. And it keeps its pollen on little bits at top. The only animal that can get into that is a bird called a honeycreeper that has a really long beak. All right. And so only the honey creeper has a beak big enough to get into that flower. And the reason that that works is the lobelia flower knows with its pollen up here, it's going to get its pollen on the top of the honey creeper. And the honey creeper knows that he's the only one who can eat the lobelia. So he knows the next time he sees a lobelia, there's probably food for him. All right. It works for the both of them because, like for the lobelia, if you have pollen for a rose and you drop it on a daisy, that pollen is wasted, completely wasted. All the energy to make it, wasted. So the lobelia knows if that honey creeper is the only one that can eat his nectar, most likely he's going to another lobelia flower for his next part of his meal, and the pollen doesn't get wasted. So it works really well for the both of them. They are both specialists. However, they only work while the ecosystem stays stable. If some sort of fungus started killing off the plants, the honey creepers would also die. If some new predator was introduced into the area and it ate up all the honey creepers, the lobelia wouldn't have anybody to pollinate. So they work great, really, really great when the ecosystem is stable. The generalists, they can handle any sort of change in the ecosystem. They have a lot more competition to find their food, but they have a lot more food available. So we talked about specialist and generalist. And then the next day we talked about the native, also called endemic, and non-native. And they are exactly what they sound like. The native species. Nehemiah, where'd you go, baby? I don't see you, man. Antonio, can you get into your camera better? All right. The native species are also called endemic species. All right, that's their names, and they are exactly what they sound like. They originated there, they evolved there, they match this ecosystem, they've always been there. Non-native is exactly what that sounds like. Either they migrated up there on their own, or they got plopped into the place by humans. Either way, they're not native, they did not belong there. Now, they're not always bad. Non-natives are not always bad. Sometimes they're actually very good for the ecosystem. All right, but a lot of times they are not good. And they can overpopulate easily because the non-natives, they don't have any natural predators. They don't have any natural diseases that keep the population in check. And they can overexpand and overpopulate the place really, really quickly. All right. And so when the non-natives become bad, we call them invasive. And we talked about the invasives the last time we had our discussion. Today, we're moving on to begin with keystone species. Do you see my picture right here? You can see my picture? Okay. The keystone, what it is, when the ancient Romans, it's an architecture thing. When the ancient Romans started building these arches, okay, they didn't even need mortar. You know, mortar is the stuff that holds brick together. They didn't even need that. They just cut the stones to fit. And then they got this trapezoid looking one at the very top, and it holds the arch together. You take that trapezoid out and the whole thing falls down. Okay, it started off with architecture, but it works the same for animals as well. Our first example here, let me pull this out so you can see it. Alligators, okay? Do you see how the alligator is up here on the top? He forms the keystone for this little ecosystem that he set up here. All right, let me tell you how alligators work, how alligators are keystone species. Okay, it starts off, you know, Florida's hot, right? Is everybody focusing and listening? Everybody's good? Shanjali, I don't see you, sweetie. Nehemiah, I still don't see you, man. All right, so starts off, you know, Florida's hot, and alligators are cold-blooded, and that doesn't mean they're cold. That means whatever temperature the outside world is, they are that same temperature. That's what it means to be cold-blooded. It doesn't mean cold. All right, so when it's like 115 and 120 degrees out in Florida in the summertime, that alligator is 115 and 125 degrees, and it sucks. Alligators can smell water. And you know, Florida, the water's just right beneath the surface, okay? Because the ocean's right there. What alligators do, because they can smell water, is they will dig themselves a hole when they can tell that the water's close, so they can just kind of sit there in that puddle and cool off a little bit. And then as the alligator grows, of course, he needs a bigger puddle and a bigger puddle. All right, so eventually you wind up making a whole little pond. They call it a gator hole. It turns into a little pond. And not just the alligator is hot, the birds are hot, the bugs are hot. Everybody comes and gets a little drink out of his water hole. And the raccoons. And what starts happening is that because that alligator has built this gator hole, the birds know the water will be there and they build their nest nearby. And because they built their nest, the raccoons know they can get the eggs. And somehow, I don't even know how this works, somehow even fish. Maybe the fish eggs were in the poo of the birds. I don't know how the fish get into the system, but pretty soon there's even fish. All right. And so you have this whole little ecosystem built up just because the alligator got hot. And he sets himself up like you have, if this is the top and the gator hole's down here, he sets himself up a little shelf down in here just under the surface where he sits here and chills out. If it is winter time in Florida and he's cold, or anytime he's just ready to chill and he doesn't want to get in the water, he gets up in here in this little shelf, and he's cold-blooded. Cold-blooded animals only need to eat like once a month or so. So yes, every once in a while, he's going to eat a raccoon or one of these bigger birds, but not often, once a month. And the rest of the time, the animals are happy to live just right in there. And only because the alligator got hot and he created a hole, a water hole, and they all live there. So he is a keystone species. If you remove that alligator, like if somebody takes the alligator and wants to make a belt or a purse out of him, or he starts killing too many of a farmer's cattle and they call him a nuisance beast and they kill him, then if he leaves that water hole will dry up and all of the other animals are gone as well. So he is a keystone species. He created the ecosystem, he maintains it, and without him, the thing is gone. So he is the keystone that holds it together. Shark is another one. Let me show you our picture of our shark. Whoops. Let's do that and then this. All right. And here, now we can see the sharks, and I can see most of y'all. Let me see. Let me see what I can do. Yeah, there we go. That works. And now I can still see everybody. Awesome. All right. So the sharks are also a keystone species. He doesn't create an ecosystem. It's the ocean. It's already there. But what he does do is he maintains the mid-level predator population. You see all these stingrays? And he doesn't only eat stingrays. He also eats big fish. Any kind of medium level size predator, he eats them up. Do you see these little guys on the bottom? Do y'all see what my picture I'm talking about here? You see these little guys here on the bottom. Their job is to keep the bottom clean and to keep the algae from growing on top of all the coral reefs. You know, if algae covers a coral reef, the coral reef is going to die. And so they keep the coral reef clean. They keep the bottoms clean. They keep all of this other stuff, the rest of the ecosystem maintained. And if the sharks are all gone, there's too many of these mid-level predators, and the little guys aren't there to clean up. All right, so one of the main things that's happening, and what your worksheet today covers, is shark finning. A lot of the shark fin soup is like a delicacy, and they take the shark's fin and just dump him back in the ocean to die. It's horrendous. You'll see the paper when you read it. It's horrendous. But if he's not there to keep these mid-level predators under control, then the little guys are not going to be able to be there. They're going to eat up all the little guys, and the little guys are the ones keeping everything clean and keeping everything running. So the sharks are also a keystone species. All right, I do have a short clip to show you right now. Let's see, let me make sure that I shared with sound. I'm pretty sure I did. I'm going to unshare and reshare my screen. Just a second. Oh, that's what I did. It's over here. Unshare and reshare with sound. Okay, I'm pretty sure that I did. I just don't remember. And now I've got to readjust everything. Give me 2 seconds. Got to get it readjusted. Because I want you to see this video about the wolves as a keystone species. We watched it once before. And I'm going to be joining Teams on my phone so that I can actually still see your cameras. I can still see your cameras. So I'm going to go ahead and let this get full screen and so we can watch it together. Pay good attention. Hang on. Now somebody give me a thumbs up. Can you hear him howling? Okay, alrighty. Thank you, babe. Get this back full screen again.
One of the most exciting scientific findings of the past half-century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic example is what happened in the Yellowstone National Park in the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. Before the wolves turned up, they'd been absent for 70 years. That the numbers of deer, because there was nothing to hunt them, had built up and built up in the Yellowstone Park, and despite efforts by humans to control them, they'd managed to reduce much of the vegetation there to almost nothing. They'd just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. And as soon as that happened, the birds started moving in. The number of songbirds and migratory birds started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes. And as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. The wolves changed the behavior of the rivers. They began to meander less. There was less erosion. The channels narrowed, more pools formed, more riffle sections, all of which were great for wildlife habitats. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land,
Sorry, guys.
but also its physical geography.
And sisters. Okay, so that is the wolves as a keystone species. Okay, and not only did I was going to try to catch it as I went in, but the lady came in to tell me they're drilling at lunchtime. Not only are the wolves a keystone species, but the beavers are as well. And so once and we didn't take the wolves in the 1700s. The reason the wolves were removed is we were afraid of them. Wolves are amazing hunters. All right. They were taking the people's sheep as they were working there. They were taking the cats and dogs, and they took a couple of children. All right. So we were afraid of them. So we took them out and we killed almost every one of them. And when we brought them back in the 90s, it wasn't because we said, it wasn't because, oh, well, maybe it'll help this other stuff. Maybe they can do this work. No, we didn't even know. We had no idea. We brought them back because it was the right thing to do. They belonged there, and it was our fault they were gone. So, but once we did bring them back, we realized all of these other benefits. We didn't even, they thought the aspen trees, they thought something was killing the aspen trees. They thought that they had some sort of disease or whatever. They were gone. No, it was the blinking deer eating them all to pieces before they had a chance to grow. So once they put the wolves in, then the wolves were chasing the deer, and then the aspen started to grow back. And once the aspen grew back, then the beavers came back, and now we have two keystone species helping to fix the place in the place of one. So it was actually a really big, huge discovery once we realized what was happening. And so that's the wolves as a keystone species. And then I think this right here, this last one here are the otters. All right. Now, before we could make coats out of, polyurethane and the comforters and the down cushions and all the stuff we make coats out of now, people wore fur. They didn't have a choice. All right. Now, if you're going to have a fur coat in the middle of wintertime, you want one that's water repellent. Sea otter's fur is water repellent. And so the people who had to wear fur, they wanted the heck out of a sea otter hat or a sea otter coat. And so they hunted them almost to nothing. All right, sea otters eat these little purple urchins down here. Can you see this little down here? Sea otters eat these little purple urchins. These purple urchins eat the bottoms of the kelp. Now, this kelp in this picture looks like it's only maybe 3-4 feet tall. 3-4 stories tall. This stuff is as big as a skyscraper. It is huge from the bottom to the top. They're called kelp forest. Okay, it's algae. I don't know how the heck algae can be that big, but it's algae. Okay, growing that tall. All right, so tall that they create forests, seahorses and seals and all sorts of animals living in there. When the sea otters were gone, those purple urchins, overpopulated, completely ate up every last bit of this kelp. They didn't eat the kelp, they just ate the bottoms. And the rest of it just sat there and rotted. And so they called these things urchin barrens. And after we, came to our senses, we stopped killing them all, we let them repopulate. Now all of a sudden, the kelp forest is back. They're a keystone species. All right. Now, the last one we have is indicator species. That's the last one. Okay. Indicator species are exactly what they sound like. 100%. They are exactly what they sound like. All right, Nehemiah, can you get back in the camera for me? All right, Antonio, can you get back up in? Marquette, Maya, Zonisha. Okay. All righty. All right, so indicator species are exactly what they sound like. They indicate the health of the ecosystem. Frogs are one of the best ones. I've got a set of 4 right here. 4 here. All right. Um, Frogs are a really good example because frogs have that slimy skin. A lot of people don't know they actually breathe through their skin. Yes, they breathe through their mouth, but they can also breathe through their skin. All right. And so with the fact that they have to keep slimy and they can breathe through their skin, if there's pollution or disease or climate change, the stuff is drier than it's supposed to be, they are really, really, really sensitive, especially to pollution. And if you have an ecosystem that had a whole bunch of frogs in it and all of a sudden the frogs are gone, that's an indicator that something's messed up with your ecosystem. They're an indicator. So it's either their presence or their absence that lets you know something is up. With the frog, it's their absence that lets you know something bad has happened. Other things, it's their present. If all they sudden show up, then you know something is bad. And I don't have a good ecosystem example, but I got a real good house example. Okay, let's say you got your house, you keep it clean. All of a sudden you get a depression and you just stop cleaning your house. You just can't get yourself up anymore. And now all of a sudden you got cockroaches. That's an indicator that something is wrong. Okay, that's what the indicator species do. Okay, they indicate the health of your ecosystem. Nothing more than that. Okay, this little yellow warbler, okay, is one. I can't remember the details behind it. Also, the monarch butterfly, the frog I just told you, and this last one is this little pika. Okay, he's a mousy looking thing. Lives up in the northern forests. Okay, this pika, if he's gone, then you know something bad has happened to your ecosystem. All right, there's a little clip here on the pika, okay, but I'm not going to take the time to show it to you right now. All right, so going through with our summary, remember that's the last of the discussion. I'm going to go over a quick review. Does anybody have any questions about the keystone species and the indicator species? Y'all good? Okay. All right. Yep. All right. So knowing our 4 this and that's, when you're getting ready for the test on Friday, you need to know niche and habitat, generalist versus specialist, native versus non-native, keystone versus indicator. So you need to know the 4 this and that's. Okay. And this goes over some of the details for you. And then after that, we have today, here's the wolves video that I just showed you, the pika, and another one about keystone species if you have any questions at all about how to do this. I'm going to turn you loose in just a few minutes to work on your assignment. If you don't have any more questions, I'm going to go ahead and stop the video. If I can pull this back over and stop our recording.